Welcome to today's webinar, Test Your Android App with Espresso and AWS Device Farm. Our presenters today are Dennis Hills and Nikhil Debati. Today with us, we also have Billy Morales, Peter Gorski, and Peter Kakandes serving as our webinar moderators. Dennis and Nikhil, welcome. The floor is now yours.
Thank you. And good morning and good afternoon to some of you. Again, my name is Dennis, and I'm a developer, mobile developer advocate here at AWS. And I have the privilege of working with you developers and various meetups and conferences. So I'm looking forward to maybe meeting some of you in the near future. What I get to do is meet with folks like yourself and talk about mobile development, what your needs are, and then go back to our developers and work on roadmaps and testing and figure out what you guys need and release those as features. And today, we're going to talk about some of the new Espresso testing, UI testing for Android apps, and testing those local and running those on physical devices on Device Farm. So the problem is a lot of developers we talk to have various devices in-house where they release these apps, they test it on a buddy's Galaxy S3, S4, whatever it might be, a Note, tablet. Then they release the app, and you can see as a screen, the app doesn't do too well with types of users like a Lollipop, 5.0, Samsung. And if you really play, let's say one of the latest games you release on Android, about half of those Android devices out there currently can't even run a more modern game. So you just got to be aware of some of those, the fragmentation of Android, some of the restrictions there when you're developing, and testing will help that. So you'll know exactly what devices will run your app successfully and which ones won't, so you know which ones to release for and how to support those. So it's really important to continuously integrate and test and know what your users are going to be running into. And so here's a picture of a farm, not our farm, but what it might look like if you're testing and connecting various devices. As you can imagine with Android, with the fragmentation of all the different types and versions out there where you have the same type of device, let's say Galaxy Note, and one is on T-Mobile, one might be Verizon, and they may have the same Lollipop version, but they could act completely different on your app. And so that's where Device Farm comes in, is where you could pick and choose different devices and integrations with those so you could test specifically for those. And I'll talk about some of those high-level use cases in a few moments. So we're going to talk about Device Farm, some testing stuff, and I'll go through the Espresso testing, and then I'll have Nikhil pass over to do the demo, and he'll run through some recording and testing local, and then run those tests with Espresso in the cloud. And so that'll be pretty exciting. So what to expect? We're going to do overview quickly of Device Farm, what it is, just so you're familiar with it, the pricing, kind of what test types we support. And then we're going to go over the very popular, recently released Espresso test framework for Android. Really excited about this. Espresso test recorder, which allows you to just pretty much record all the UI scenarios without any code. It saves it out. You build the APK, run it, and then test it on your devices. Then we'll have Nikhil walk through the test recorder, record test live on a sample app that we have, and you can follow along as well. And then running recorded tests on AWS Device Farm, so you'll be able to see some of those reports, the logging, all the other things that come with Device Farm. And then we'll try to close out a little early for some questions and answers that you might have throughout the discussion. So let's get started. So Device Farm is just an app testing service that enables you to test and interact with Android, iOS, and web apps. So what we have is physical phones and tablets that are hosted at Amazon Web Services. So there's two main ways to use Device Farm. And the automated testing, which you may be familiar with if you've used Device Farm. So automated testing is you create these scripts, something like the Espresso or Appium or Calabash, and you can test your application on a device. And that's the automated testing piece, where you could do CLI, you could run it through the console, whatever it might be. We also offer remote access. So remote access is fairly new, where you could pick and choose your device and version, and actually run it in a web browser, upload your app there and interact with it just as if you were holding it in your hand. So it's really nice. These are physical, real devices, not rooted, open package and access there for you. And almost all the Android devices will contain the Google Play Store software if it's available. So we support Android and iOS native, hybrid, and web. Hundreds of unique physical devices in many instances. So what we have is like, we'll have an iPhone 6, iPhone 7, Android Galaxies, Notes, whatever it might be, and then different versions. So we'll have Lollipop and we'll have KitKat, all those different varieties along with the different carriers. So like we talked about before, where we may have two devices, the same manufacturer running Lollipop. One is Verizon and one might be AT&T for various reasons. As they may react different. They have their own version of Android running, and the test could be completely different. So we offer a different variety there. So that's the advantage of the cloud, is not having these multiple versions out around, so you could test on all these different varieties. So security with these devices, full hardware and software isolation, and flexibility with the manual and automated and framework. So you can support Appium, Python, Java, JUnit, instrumentation, which is what we're going to talk about with Espresso, UI Automator, Explorer. And then we also offer a fuzz test type thing. So if you don't want to have any test framework and you just want to throw the app up there, we will do fuzz tests. And what that does is just throws in a bunch of UI command random screen touches, and then it'll give you a full report with logs, and you can take a look at that and see how your app is reporting. Kind of a randomized user test framework. And then reports. The great thing is, Nikhil will show you some of these results. Videos, screenshots, logs, performance, how much memory use, all those things come with this package when you run a test on Device Farm. So it's really cool to see all the reports, and then you can report back to your customers or your manager and just say, okay, here's what we tested, here's the devices, and here's how they performed. And then you can go back to the team and figure out if you need to redo a few things or just go ahead and release it at that point. So integration. So a lot of development firms use Jenkins, for instance. We have a plugin for Jenkins so that you could do a continuous integration. You could build, and then every time you do a nightly build or every time you do a new build, it can run a certain amount of set devices in the pool in Device Farm. Android Studio, you could use SDKs or the CLI to integrate with Device Farm as well. So pricing, let's talk about that a little bit. This is a common question about pricing and the various options that we provide. So we have unlimited testing, which is $250 per slot per device. And what that is unmetered plans allowing unlimited testing and remote access at $250 per device slot. So these are slots that you can choose the device family, Android or iOS, and then you cancel anytime, and then you could add remote device slots at any time. And you purchase device slot, and then it corresponds to concurrency if you need that. We also have the default pay-as-you-go, 17 cents per device per minute. That includes both the automated testing and the remote access through the website. And we offer 1,000 minutes. Right now we have a special deal for 1,000 device minutes for free. So I encourage you just to test this out. If you're worried about pricing, anything, you have 1,000 minutes one time free, so you can run through several scenarios, several devices, run your app, just check it out. And then I think once you realize the benefit there, then you go back and say, okay, this is going to be really something we need to put into our plan and our waterfall and figure out how things work with our app. We also have private devices. So these are for folks who want to do VPN access, have a little more security, and they are having dedicated devices to your account. So if you need, an iPhone, you need an Android device specifically, you can do the private devices as well. And that starts at $200 per device per month. And there's no minimum number of devices for that. So it starts today with 250 minutes, which we just, that's old because we just released the 1,000 device minutes that's including the automated testing and the remote access. So availability. Often we get customers wondering if you're used to AWS, you choose the region you're in. If you're in, let's say the West Coast, you might choose Oregon or California. In this case, Device Farm is located in the US West 2 Oregon region. And it really doesn't matter what region you're in. You upload your APKs and test it out. And it doesn't matter whether you're in US East or you're in Dublin or Ireland, whatever it is, that the test will run in Oregon. So if you're in a specific region, go ahead and choose Oregon, and then you'll see the device farm there. High-level use cases. So test order changes during development, we talked about, where you just make changes and then you want to test those changes every time. You could integrate those with Jenkins, or you can upload those manually to in the console. You could test cumulative builds nightly. So let's say every night you have the builds complete and you want to run through a bunch of tests. You can run through the device farm, choose the device pools, 5, 10, 15, 20 devices, whatever you guys want to test with. And then you'll have a full report and logs to check out in the morning. And then verify functionality prior to release. Let's say you're going to release next week and you want to be able to test on X number of devices. Really important before you release, just test it on physical devices. Really important. I've seen it all the time where developers will use simulators and everything works great, and then they go to physical devices and things just don't work. And with our devices, you can take pictures, you can do the rotation, you could do geolocation, all the things that you could think about doing with a physical device, you can do with our devices in the cloud. So you kind of just play with it like it's really in your hands, except for you're not touching it. So monitor release applications, canaries, very important. So let's say every day you want to test the app on these various devices on a daily basis. This is a production app, just make sure everything's working, throw out some canaries, use it that way. Reproduce issues reported by analytics and end users. This goes back to that point where we talked about two same devices running the same lollipop version, but maybe one's on AT&T, one's on Verizon. It's a very common use case where everything could be running great except for the Verizon lollipop. And so what customers will see there, it's like maybe they don't even have the device. So what they'll do is come to Device Farm, check out some of those devices and run those tests and then validate things exactly where, and they could pinpoint with the logs, the video, they could pinpoint exactly where the problem is, and then release a new version of the app, or contact those users and say, hey, we found the problem. So that's this device farm. Now we're going to talk about the Espresso test framework, because that's what we're here about. We're going to have some fun with that. So the Espresso testing framework, it's an instrumentation-based API for functional UI testing within an app. So released recently, provided by the Android Testing Support Library. It provides APIs for writing the UI test to simulate user interactions with a single target app. So that's what Nikhil is going to do. He's going to pull up Android Studio, pull up a sample app, and he's going to record a few tests, add some asserts like this is what the text should look like, save it out, and then you save it as an APK, and you can run it locally, or we can run it in the cloud, which we're going to upload it into a few Android devices in Device Farm. So flexible APIs. So you could use view and adapter matching and automated UI interaction. Some of you may be familiar with Espresso already, but this is some of the overview of the advantages of writing UI tests. So you can simulate user interactions like clicking a button, adding text, and then you could verify, like if somebody adds a text or puts a certain character in, you could assert that, figure out exactly what text you could put in there. And then you save it out and all the code's written there for you. And then you save it out and run it up on the devices. So it runs on devices running Android 2.3.3, which is API level 10 or above, which is pretty much hopefully 90% of your devices that you're going to run on. Automatic synchronization of test actions with the UI application. Now what this means is it can detect when the main thread is idle for improved test reliability. Really important if you've ran tests and it's just not quite reliable. You're not sure if it's the test or the device or the app, whatever it is. This is really important because we don't have to put any more thread sleeps. We don't have to wait for the UI. It just automatically knows that the main thread is idle and it runs through. And it works with Android JUnit runner, which is the JUnit 4 compatible test runner, an instrumentation that runs the JUnit 3 or 4 test against an Android application if you're used to the JUnit test. So now for the Espresso demo, because I think seeing it in action is really important to be able to see it run locally, set up the demo. Nikhil's going to walk you through creating a UI test with the Espresso test recorder within Android Studio. And the test recorder allows you to create UI tests for your app without writing any test code. And with the test recorder, you can simply start recording the test scenario, stop and assert anytime you're gonna add a few things to it. And then you save the recording, and then automatically, which is kind of magic, it saves out as an APK, and then he'll run it through Android Studio, and you'll see the tests run through, and you'll see the results, which is okay. But then really when the fun part comes in is when he uploads that APK along with the application, and then runs those Espresso tests in the AWS Device Farm cloud on these devices is really when you're gonna see the results come out. So I'll pass it over to Nikhil.
Okay, thank you, Dennis. Hello, everyone. I'll be walking you through the Espresso test recorder and Android Studio functionality to tell you how can you record your test without actually knowing anything about Espresso or even knowing how do you write unit tests or UI tests. It's a simple tool that gets you started even in the most basic cases. If you have an app or even if you don't have an app, we can get you started with a sample app. So what am I going to do on a high level? On a high level, I think Dennis already mentioned this, but we're gonna use Android Studio, record tests using the Espresso recorder. Then we're going to run these recorded tests locally from Android Studio. Then we're going to generate the APKs for the app and the test. So Espresso is an instrumented test. So when you say instrumented formal test, the tests are in the form of an APK and they run on the device. The third is once we have these APKs and tests, those are the two artifacts amongst others that you can supply to Device Farm to run your app and test. We're going to upload these test and app packages to Device Farm. And we'll see how do they execute on Device Farm across multiple devices. And then we'll jump into one of the powerful features of Device Farm, which is the reporting, that how does it break the results for you? It points out the errors that you would usually may not be able to immediately find out. And you can gather data based on this and make your app better over time. So right now, after this is done, I'll be switching my screen to show you the Android Studio here. So here I'm in the Android Studio. To get started, we need an app. So we're going to record our test, but we need an app against which we want to record our test. Where do you find this app? We have a GitHub repository. If you go on github.com and just search for AWS Device Farm, you'll find a number of sample apps, Android, iOS, web applications that we host just to get users started. These apps primarily show the different type of components that an app in today's world can have, different types of UI interactions, checkboxes, image scrolling, video playing, camera capture, and all those other things. For the purpose of this walkthrough, I'll be using the AWS Device Farm sample app for Android. It's under the AWS Labs handle over here. Apart from just the app, you can also find on the GitHub page, it has a number of test code links over here. So you can see it has Espresso, Calabash, Appium, and all that's going to do is it's going to take you the corresponding test for this particular app in this different type of test framework. So we also provide you a way to get started with different types of test framework, and you can use these as a template code to see how can you write Appium or Calabash tests. And they also reflect the best practices that you want to do while running tests on Device Farm. So switching back to Android Studio, here I have the AWS Device Farm sample app for Android open. To show you how it looks and feels, I already have it open in my emulator over here. So this is my app. That's the menu. So as you can see, there are a number of options. You have the home, web. Since we have a web view over here, this also makes this a hybrid app. So Device Farm not only supports native, but as Dennis touched on, it supports native, hybrid, and pure web applications too. So this app is native and hybrid. We also have native components like your camera, your video recording. Then we have different types of input controls here, checkboxes, radio buttons. Going back here, there's also a login page that typically most apps have today. And then there's an alert page here that shows different types of alerts. You can do toast, and there's an alert pop-up. So what we'll do is we'll record tests for one of these UI interactions. So if you had to say, well, can I see whether the alert box works perfectly fine? You want to go to the menu, click on the alert, and go and verify whether the alert button is there, and then click on it. So we can write a simple test that just captures this UI interaction and then translates this to a test APK, which we can run on an emulator. But more importantly here, we can run it on Device Farm, and you can just see how simple it is if you want to run it on Device Farm. Now, how do you get started with Espresso Recorder? So this was launched recently. Android Studio comes now bundled with a Espresso Recorder. You can find it under the Run menu option. There's an option called Record Espresso Test. Once you click on it, it's going to ask me a deployment target. For the purpose of this, I'll be running this on an emulator. So once I run this, it should pop up a dialog box for me that says the Espresso Recorder test interface. In this dialog box, for the ease of seeing how this actually works, you want to have the emulator on the side along with your test. So let's say the first thing I want to do is click on the menu. As soon as I click on the menu in the emulator, you see that it recorded a UI interaction on the right side. It says tap image button with content description reference app. So in this case, the menu button had a content description called reference app, and it tapped on that. So that's a UI interaction we recorded. Now I would want to go to the alert option. So I click on alert. Once I click on alert, you can see that it automatically registered a UI interaction saying tap recycler view, and it picked up the position of the alert menu option from the menu. Now let's say I want to add an assertion here. So I would say add an assertion. What I want to do is I would just first want to check whether the button is present at all. So I would say add an assertion. As soon as I add an assertion, there were a few messages that popped up. And the way this works is it captures the UI hierarchy of your app. So whatever is on the screen, it represents that in the form of an XML internally, and then puts it out for the user. If you've used other testing frameworks like Appium, Appium provides the same similar functionality where you can inspect the app, see what's on your screen, and then inspect the elements of the app by looking at different types like content ID, resource, description, and other useful information. So as you can see, if I hover around here, it shows a red boundary or background over there on the elements. So I want to say whether the alert box is present over here. So as soon as I hover around it, it shows that red box. I click on it. Here on the assert box, you can see that it showed me the ID of that element. This is the unique ID by which the element is identified in the app. And the simple assertion is whether it exists or it doesn't exist. In this case, let's say we want to say that does it exist? And I can say save assertion. Once it says assertion, you can see that it registered an assert button with ID, whether the alert button exists. Now switching back to the emulator here. So let's say we want to keep it only to this one in the test. We can expand this test later. So let's say I'll click OK. Let's name this test as alert tests. So once it's given the name, what it's going to do is go ahead and generate the test code for this. So you can see on the left side here in the Project Explorer, it created an alert test class under activities package. And we did few things, right? We clicked on the reference menu app. So you can see here, it does a perform click in the auto-generated code. Then we also went ahead and clicked on the navigation menu and clicked on another option over there called alert. It did that. And then you can see that finally it clicked on the button and did a check. So that's our implicit assertion over here that it generated for us. So on a high level, it generated the class. It supports JUnit annotations here. So it does alert test. If you scroll down, it generates a alert test over here inside alert test class. Once we have that, we want to see how this runs locally. So in order to do that, we need a run configuration. So in Android Studio, everything, if you want to run an app, you need to have a configuration. That configuration tells it which package to run, which SDK to target, and other information. So in order to run a test, we also need a test configuration. So we go here, let's call it edit configuration. Here you'll see a variety of options like Android app, Android instrumented test. We want Android instrumented test since Espresso is a type of instrumented test. So we'll say add new configuration, say Android instrumented test. Let's call it my grade config. And then let's say module, that should be the app. Now we want to run all the tests. Since we generated only one test class, let's run all the tests under the package activities. So I go to com, Amazon AWS Device Farm, Android, reference app, and then activities. So I gave it the package under which I want to run all the tests. And I'm going to save this here. Once I have this saved, I'll just go ahead and run it, and it will be run against the emulator again. So ideally, what it should happen here in the background is it should install the install the app APK, install the test APK, and there you go. You can see that in action, and there you go. So your test ran successfully here. So that was a simple test. As you can see, even if I knew nothing about how do you write Espresso test, I actually generated a unit test over here without knowing anything about even Java at all, or just Android in general. So once we have run these tests, what we want to do is we want to have the APK file for both the test and the application. How do we do that? We go under build and say build APK. And then build APK, we have the Gradle still running on the test. It's trying to finish up the test results. So that test ran. Now it's going to trigger the build APK generated successfully. So it has it generated in the Finder. Where do you find this test in the Finder? So you go to Finder. So I had my sample Android app under GitHub folder over here. So under my app, there should be a build, outputs, APK, and then you can see these two apps that were generated. So what I'm going to do is I'm going to use these two apps and upload it to Device Farm. Now, switching back to Device Farm, how do you get to Device Farm? Right now, I'm here in the main AWS console. So as you can see, we have a number of AWS services over here. Device Farm is a mobile service, so it will live under the mobile services section here in Device Farm. So we go ahead and click on there. Now here's the main display. You can see a layout in terms of projects these are logical containers that contain one or more of your runs. Your runs can have one or more tests. So you can think that if you say you have a continuous integration, you will be triggering runs, and each of those runs will have one or more of your tests. So I'll go ahead and create a new project here. Let's call this my greatest app or my greatest project. Once I go into the project, you'll see the two types of offerings from Device Farm. One is the automated tested, and the other one is the remote access. I'll quickly touch on the remote access piece too. Right now, we want to do the automated test, but remote access is a really powerful feature that lets you access a real device. Note, these are not emulators or simulators. These are real devices in the cloud that you can access inside your browser and actually quickly do a sanity check or test on your app that you want to test. So I'll start a new run here for automated test. Now, on a very high level, there are 5 steps to Device Farm. The first one is you provided the application. Second step is you provide the test. And in our case, we have both of those in the form of APKs. In the third step, you select the devices against which you want to run these tests. There's also a step number 4 where you can specify initial device state. I'll touch on these in detail. And then you just kick off the run. Now, when we want to choose an application, we support Android. We support Android and iOS, both native web and hybrid applications. So since we have an APK file here, it's a native app. So I'll go ahead and say upload. I'll take my app over here. Now, while this is being uploaded, it also does a number of things. It will parse your app. It will try to look at the metadata of the app. So examples of metadata of your app could be, it looks at the SDK version, the minimum SDK version, the target SDK version. It will also look at the API level, the screen resolution that might be supported or it's assigned to, saying, well, run my device only on these screens. These are typically things that you can find in your Android manifest XML. So as you can see here, it parsed it. It gives you package, activity, minimum SDK, target SDK, even the version of your app. You can assign a run name to your app. By default, it takes the APK. I'm going to keep it what it is on the default. Next, so there are 2 categories of tests on a higher level. One is the built-in test, and the other ones are the actual automated tests. So if you have written your own automated tests, we support a number of popular testing frameworks out there today, namely Appium, Calabash, Instrumentation, UI Automator. We also support multiple flavors of Appium, namely JUnit, TestNG, and Python. Say you haven't written your tests. These were the cases that I just mentioned before are the ones where you already know how to do UI automation, or you already know how to write mobile tests. But to say if you don't have any test at all, in that case, we have you covered with Builtin Explorer and Fuzz. Builtin Explorer, as the name suggests, it explores your app. So every test that happens within the scope of your app. What it does, it looks up your app, analyzes the UI elements the same way Espresso Recorder does. It takes a dump, and then it tries to go as deep as possible for every UI interaction that may be possible in this. So if I gave it our sample app, it will try to go to the menu and try and go through every single menu option that is there while it's doing this Explorer test. It can also take a username and password. This is typically if your Explorer test, if you remember, we had a login page over there. It had a username and password field, so you can provide the username and password, and whenever it finds a username and password field, it will pick up that. Fuzz test. Fuzz test is, as the name suggests, fuzz. It's a random event inducer, but the scope of this test is not restricted to your app, but across your entire device. So imagine cases you want to see how your device and your app react when you are inducing random events. Think like scrolling down the notification bar, changing something in the control center, pressing the back button, switching between applications. So you cannot really dictate the events that will happen. The whole point of this test is it's supposed to be random, and these can be useful in quick sanity tests where you want to see how does your app stand up against different interactions on the screen. You can provide a few parameters over here. Event count is how many events do you want to induce in the app. Throttle is what's the time difference between those any two events, and randomizer seed is a randomizer seed which will change the entire random events based on the value of the seed. Now, since we did an Espresso Recorder here, it's a type of instrumentation test. So I'll go ahead and select instrumentation, and I'll say upload. Android Studio generated the test for us, so I'll upload that test. Now, while it's scanning your app, your test here, it's also doing some pre-processing on the test package. It's looking whether your tests were parsed correctly, whether there's any obvious errors in that. It does not look at your code, but it looks at the metadata and the structure of your package, test package, and does some analysis for you. If it finds anything, it bubbles up the errors and say, hey, you may have a folder structure that's different from what the test framework expects. Say, for example, if you're using Calabash, and if you don't have a feature folder, or if you have recursive feature folders, that's something that might go against how Calabash recommends writing the test, and so it will pop up the error and bubble it up. So here it also did a parsing on a higher level, showing you the test package and the runner. Dennis touched in one of his slides that by default, Espresso uses the Android JUnit runner. We also support test filters. Say we had just one alert test in our whole Espresso test recorder session. If we want to run just that single test or single class, you can specify the test filter over here with the fully qualified package name. It can go as granular as the method name. So you can specify that here. You press on next. Now here is, by default, you'll see devices over here selected for you. What are these? So these by default is a top devices pool. This is a curated pool that we maintain based on n number of factors, but mostly two, which is which devices are more popular with the customers and which devices are being used a lot in the market today. Based on those two primarily and other factors, we keep on updating the top device pool depending on what data we get from the market. And then we provide a top device pool for you by default. However, this top device pool may not suffice to everyone's need. In that case, what do? We create a new device pool. Device pool, the terminology in Device Farm is, it's a group of one or more devices against which you want to run your tests. Now, we want to give it a name. So we say my great test pool. And so here is one of the really powerful offerings of Device Farm. You can see all of the devices that are present against which you can run your test. You can see n number of or operating system versions. You can also see carriers, makes, model. We also have a latest Samsung Galaxy S8 if you observe that. And these are across different make and manufacturer models, form factors. So you can also quickly say, well, give me a tablet that is running Android 6. I'll say tablet running Android 6, and there you go. You have one tablet. And let's say we want to have, for the purpose of this test, we want to have few devices. So I'll say, give me any phone running OS 6, and let's pick a Nexus phone. So if I say Nexus, LG Nexus 5X, and then let's pick a Android 5 device. I'll say Motorola Nexus 6 running Android 5, and then let's maybe pick a tablet. So if I say tablet running Android version 5, maybe an LG tablet or a Samsung tablet. So let's pick a Samsung tablet. And I'll pick one more just to have a good mix of devices over here. So we have, I think I picked 4 devices, one from each of the current widely used operating systems, so 4, 5, and 6. We could have added a 7, but I'll keep it to this for now. You can always edit. If you have to go back and edit, you can always click on the edit pool, go back, and then add on other devices. These pools are also maintained in your project settings, and you can always change these. Going to the next step. Now here are the few initial device states that you can mention. Extra data. What is extra data? Extra data could be media files, configuration files, or basically any file format that you or your app can use while the test is being executed. So imagine you have a video file that's too large and you want the application to have access to that while your test is running. You can provide that extra data in form of a zip file. This extra data gets extracted to your SD card of your device in case of Android and your application data folder in case of iOS. Other apps, imagine interactions where your app says, share this on a social network like Google+, Facebook, or Twitter, and you would require that other apps to be present on the device. In that case, you can supply these apps as extra apps. You could also have your apps from the same company or same offering that you need to be present on the device. You can supply those apps, and when your test start, these apps will be present from the start. You can also specify the radio states, Wi-Fi, Bluetooth, GPS, NFC. Of course, you can configure these on the fly depending on what testing framework are you using and if they provide a support for that. These are all the initial states that it will start off with. Device location. Think about banking apps. Features something like find me the nearest ATM centers when I'm on a particular location. Or think about cab sharing apps where the app may behave quite differently based on the device location. So you can specify the latitude and longitude in the start for the application. Device locale is the language that the device will have when the tests start executing. Network profile. This is another powerful feature from Device Farm. In today's world, you mostly have good network, but in most cases, if you're using your apps in a basement, you can have flaky network, and you don't want the app to behave differently under different network conditions, or you want the behavior to be predictable and pleasant to the user. So Device Farm by default provides a pre-populated list of network profiles, namely anything from 3G to a really lossy connection. These could be also Wi-Fi good, average, or bad connections. And this helps you emulate the network conditions on the device. If you don't have a network profile that suits your need, you can also create a new one, and you can specify all the parameters on a really granular level. I'll keep the values to what it is on the default and go next. Now, by default, there's a default timeout here. It says 16 maximum minutes per device. What this means is I selected 4 devices. It's going to run the test that I uploaded on all the 4 devices in parallel, but it's only going to execute it for 60 long minutes on per device. If you need a longer execution time, we can bump it. The reason it's capped at 60 minutes by default is imagine a case where you feel you're really confident that your tests really run within a predictable time, but they take a longer time than 60 minutes on some devices. In this way, you wouldn't want to be charged for those minutes, thinking that your app was written perfectly, but something went wrong and it's just stuck there sitting, waiting for end user interaction. Once those are configured, I'll go ahead and say confirm and start run. And let's see here. Maybe I need to refresh this here real quick. Okay, for some reason I got logged out. Sorry about that. So apologies. So if you can proceed where we left off. So I can select the instrumentation test that we generated. As you can see, I don't have to do the whole process all the way again. It will also have saved my device pool. I'll say next, next, and then confirm and start run. There you go. So it has triggered off the run for me. So if I go and click on here, you can see that it's going to run all of my tests in parallel on all of this. We'll just take a few seconds for it to kick off the run. But all of these devices that you see, we host multiple instances of each one of these devices. So if you selected a Motorola Nexus 6 5.1, it's not the case that we have only one device. There will be multiple instances, peculiarly mapping just to 5.1 that will be picked up for the execution of this test. Now, you can see these tests are executing in parallel. In the fullness of time, I'm going to go ahead and show you a run that I already had executed on the same set of devices. So going back over here, I have two runs over here. One is a detailed one. So I have a detailed one to show you how it can actually be useful for you in terms of reporting and all other features. So when we click on this, initially it shows you how many tests passed, failed, and how many were skipped. And I'll go through each one of these real quick. It shows you all of the devices, shows you the distribution of the test. Now, you may have common patterns that your app only fails on a particular set of OS versions or make and model of a device. In that case, it groups those failures for you and telling you on which devices did you see a particular error. So if I go in here on one particular device, say LG Nexus 5, so by default, we have multiple things here that will be presented. You'll find a setup suite. Setup suite is it looks for the device. Once it gets an instance of the device, it makes sure that the network is proper. There are no other apps from previous runs installed on the device, no other test artifacts present on the device from previous runs. And then when it gets a go ahead for this one, it goes ahead and then runs the tests. Once all the tests are run, you'll find a teardown suite in the end. The teardown suite removes all of the apps from your test execution, all the test artifacts, and make sure that the device is ready for the next customer. And then we go down to logs. We have three types of artifacts presented over here, or three categories. One is your harness log. These are the logs from the host machine to which your device is connected. There are also device logs. These are your log cats. This is a really cool way you can just say, show me all the errors, and it will do the whole searching for you. You can also have your log tags and info levels over here. So instead of downloading and you actually filtering, you can do all of that stuff here. And of course, in the end, you have your test logs, which is your actually logs from the actual test. All of these artifacts are downloadable, as you can see here. According to test, you have all of the outputs available. We also capture network logs and the video. So the best thing about this whole execution, let's see, go back and look at the execution that we had recorded for the alert test. If I go back here and run this, you can see the app comes up, goes on the alert box, checks this existent, and done. That's it. So that was as simple as it can be. We kept it really small. It also captures performance data of your app along the execution run. So it captures the CPU data, the memory use as per time, and then the thread count of the app under execution. It also captures the screenshots. So if I go back here to a results that has actually, since we didn't add any screenshots, we wouldn't find any here. But if I go to the one that will have captured and has a larger test suite over here, these screenshots can be triggered via your test framework. Every test framework provides a way for you to capture screenshots. If you use the Builtin Explorer and Fuzz, they capture the screenshots at every single stage for you. So if I scroll all the way down over here, you can see the different test has different screen captures over here. And this really helps you relate to say, okay, I want to check whether the UI interaction happened, and then I want to go back and see the screenshot that it actually happened. Those are all the artifacts. As you can see, it really solves the whole problem of you trying to do this locally and trying to accumulate the data and present it in a meaningful way. Now, I wanted to touch really quick here on the remote access piece too. So if I go back here, I think I should have a session here that's already running. Tells me to reload. Let's try that. Since I signed out from the AWS console previously, it's trying to go. So let me go here. So Device Farm again. And then I think I have it in the webinar. Go to remote access. I have an Apple device that's already running. Give it a while here. And what this is going to do is it's actually going to give you a device in the cloud. In my case, it's 5 seats. So right now it's initiating the session. It's going to try and find the device for me and then connect to it. And once it's connected, I can actually interact with the device. I think we have a few minutes left before we start the Q&A. So in the fullness of time, I think I'll just switch to the Q&A session. And once, if we get this, I can show you.